When we talk about AI, it's all about innovation, right? Progress. But what if the very building blocks we're using to create that progress are secretly compromised? Today, we are digging into one of the biggest yet most under-the-radar threats in AI security, malicious models that people are just downloading straight from public libraries. Okay, let's dive right in.
Now, before we really get going, just a quick heads up. This is the second explainer in our 10-part series covering AI attack vectors. What we're talking about today comes directly from Chapter 2 of the full in-depth report by Virtualization Options LLC. We're going to give you the essential overview, but believe me, the full report has a ton more detail if you want to go deeper. So here's how we're going to tackle this. First, we'll talk about what I'm calling AI's public library problem. Then we'll peel back the curtain on the attacker's playbook. After that, it's all about how you find these hidden threats, what to do to contain the damage, and finally, how you can build a fortress to keep them out in the first place.
Look, the open source movement in AI has been amazing. It's incredible that anyone can pop onto a site like Hugging Face, grab a pre-trained model, and just start building. It is absolutely supercharged innovation. But it's also blown a massive hole in our security. All that convenience from these public libraries, it comes with a really big hidden risk.
And just how big is that risk? Well, get this. According to research from Hidden Layer, a staggering 45% of AI security breaches involved malware that was baked right into models pulled from these public spots. 45%. That is nearly half. This isn't some fringe issue. It's a mainstream attack, and it is working.
So you might be asking, why is this happening on such a large scale? It really boils down to this quote from the report. It's a problem of trust. You've got developers under immense pressure to move fast, to innovate. They see a popular model, it's got great reviews, and they just assume it's safe. Speed and convenience win out over deep security checks, and that creates the perfect storm for these bad models to spread like wildfire.
All right, let's flip the script for a second and look at this from the attacker's point of view. This is not some simple virus upload, no. This is a sophisticated, step-by-step plan designed to weaponize a model and trick as many people as possible into using it.
First off, let's be super clear about what a malicious AI model even is. We're not just talking about a bad piece of software that's attached to a model. No, the harmful stuff is embedded inside the model itself. We're talking deep within the neural network weights, the architecture, or the scripts that make it run. It's basically a supply chain attack, but at the AI level.
Now, what's really fascinating here is just how patient these attackers are. They play the long game, and it's a four-stage playbook. First, they compromise the model, sneaking in a back door or some data-stealing code. Second, and this is clever, they build up its reputation with fake reviews and really good documentation. Third, they just wait. They let it get distributed far and wide. And only then, once it's deeply embedded in countless systems, do they pull the trigger on the final stage, activation.
Okay, so we get it. The threat is out there, it's real, and we know how the bad guys operate. So the next big question is, how on earth do we find these things? This is where we get into what's basically digital forensics for AI. And this really is the heart of the problem, isn't it? How do you find a threat that isn't just a file you can scan, but a subtle mathematical trick hidden among billions of parameters inside a neural network? It's the ultimate digital needle-in-a-haystack problem.
Thankfully, security teams aren't flying completely blind. They've got a few key methods. First is automated artifact scanning, basically looking for known malware signatures in all the files that make up the model. Second is behavioral analysis, and this one is so important. You run the model in a safe, isolated environment, a sandbox, and you just watch what it does. Does your language model suddenly try to connect to the internet? That's a massive red flag. And finally, there's provenance and integrity verification, which is all about making sure the model's entire history, its chain of custody, is legit.
Okay, so let's imagine the worst has happened. You've used those techniques, and you've found a compromised model running in your systems. The alarm bells are going off. So what do you do next? The key is having a clear, ready-to-go plan for remediation.
Your immediate response needs to have 3 top priorities. Step 1, containment. Get that model offline, now. Disconnect it from everything. Step 2, rollback. You switch back to the last version of the model you knew was clean and safe. And this, by the way, is a perfect example of why version control for models is absolutely critical. Step 3, impact assessment. Now you have to figure out, what did it see? What data did it touch? What bad decisions might it have made?
But you can't just stop there. Finding one bad apple means you have to assume the whole barrel might be spoiled. You've got to launch a system-wide review. Search your entire infrastructure for any other copies of that same model.
Then go look at every other model you downloaded from the same person or company, because a single bad model could mean the whole source is compromised. And finally, you have to comb through your logs to see if there were earlier signs of trouble that you might have missed.
Of course, the best incident response is not having an incident at all. So this brings us to the most important part. How do we build a fortress to proactively defend against these threats right from the start?
This slide just nails the two different mindsets, doesn't it? You've got the fast, insecure way, download, run a quick test, deploy it, and then just hope for the best. And then you have the secure way. It takes more discipline for sure. You vet the source, you test the model's behavior in a sandbox, you continuously monitor it after it's live, and only then can you deploy with actual confidence.
So the foundation of this fortress really rests on these 4 key pillars. First, strict vetting procedures for any new model that comes in the door. Second, managing an internal trusted registry of models that you've already approved. Third, continuous runtime monitoring to spot weird behavior in production. And maybe the most important one, fostering a real culture of security, where protecting the system is everybody's job.
And that really brings us to the final critical question that this whole thing raises. The pressure to innovate with AI is just immense, but it's forcing a really dangerous trade-off. In our collective race to build the future with this technology, are we moving so fast that we're completely forgetting to build it safely? That's something every single organization using AI really needs to be asking itself.